Welcome everybody. Thank you for attending my talk. The topic of today is test-driven development and generative AI. And together we're going to see if this is a perfect pairing. So I would like to start with the why. Why am I here talking about this subject? So last year I had a talk called The Battle of the AI Coding Assistants. I gave it at multiple meetups and multiple conferences, also at this conference last year. And in this talk, I compared features of different AI coding assistants. Think GitHub Copilot, JetBrains AI assistant, but also good old JetGPT. One of the features that I showed off was the fact that they are pretty capable of generating tests. In almost every case, you get a happy flow. In most cases, you get some edge cases. And if you're still not happy, you just ask for a few more until you have a nice full test suite. After one of those conferences, somebody came up to me and asked, "Hey Bouke, that's very nice, but why don't you do it the other way around?" Sorry, I'm forgetting something. So let's step back a little bit. Generating tests, how does that work with AI? You, as a human, write the implementation, you give it to AI, and you're asking for test cases. And this works pretty well. Then somebody came up to me and said, "Hey Bouke, why don't you do it the other way around?" I said, "What do you mean the other way around?" And so first you write your test, you give the test to AI, and then you ask for an implementation. And I said, "Cool, that's an interesting idea. I don't know if it works. I'm going to try out and I'm going to get back to you." Investigating this idea led to this talk. So the second thing I would like to do is a dissection of the title. So let's repeat the title. The title is TDD and GenAI, a perfect pairing. There are three IT concepts in this title, and the first two, of course, are plainly obvious. The first one is TDD, test-driven development, and the second one also really obvious, generative AI. But the third one is a little bit hidden. Who dares to venture a guess? Yeah, very good. The answer is pair programming. So that's the third concept. What we're going to do, we're going to try to combine those three IT concepts into something new. But before I'm going to do that, I first would like to take a minute to talk about all three concepts so we're all on the same page. So let's start with GenAI. JetGPT is the most famous one. It's introduced a little bit more than 2 years ago and it made a big splash in the world. Since then, all big IT companies created their own AI assistants and they have one thing in common. They all run on a technique called a large language model. And those models are really good at generating text, but also pretty good at generating code. And that's the thing that we're going to do today. Secondly, we have test-driven development. People hold entire conferences about this subject. But for this presentation, I'm going to boil it down to write tests in advance. This is better than the other way around for multiple reasons, but there are two reasons I really like. And the first reason is the fact that if you first write your implementation and then your test will be biased by your implementation. We do not want biased tests. Secondly, I really believe in the following. The more you think about something, the better the end result will be. So if you first write your tests, you think a lot about your implementation, therefore you will write a better implementation. Also, not unimportantly, it goes really well with pair programming. So let's talk about that. So pair programming, really simple, you write software in pairs. You sit together behind a computer and you write your software. So normally we have two roles. We have the driver, that's the one sitting behind the keyboard typing the code. But we also have the observer or navigator, that's the person we are discussing with, and that's the person who is giving live feedback on your code. So another thing you do a lot while doing pair programming is one person writes the test, you switch chairs, and the other person writes the implementation. So, can we combine those three IT concepts in something new? Can we combine it into a perfect tripling? So this is the idea. We're going to pair program with GenAI. The human will write the tests. The AI will try to write the implementation. And we call this test-driven generation, TDG. So, something I didn't talk about yet is the fact that tests have a double purpose. And I already talked about the first purpose of tests. We're going to use the test as input for AI. That is where it's going to base its implementation upon. But I think the second purpose is even more important. We're going to use the test also to check the output of the large language model for correctness. So you've been playing with LLMs in the last 2 years, and you all have seen that they sometimes hallucinate and that they sometimes make things up. And that's a problem. Let me illustrate this problem by telling you a little story. So this was in the news in the beginning of the year. It's about Air Canada, which is an airliner. They have a website, and on their website they have a chatbot. And they decided to improve the chatbot by using a large language model. And this in itself is a proper idea, right? Because your chatbot will give more human-like answers. And I hear somebody laughing in the audience. You know the story? Yes. So they did this, and the customer was chatting with this chatbot, and they were talking about refund policies. And as you probably already imagined, the chatbot started to make things up. It invented a refund policy. So the customer was foresighted, made screenshots. A few weeks, nothing happened, but then suddenly the customer decided to make use of his refund policy. So he called the help desk with actual humans behind it. And he asked for a refund. And the human said, "Sorry, sir, but this is impossible. You cannot get a refund." He said, yes, look, here, I have screenshots. The chatbot told me I am eligible for a refund. He said, "No, sorry, sir, the chatbot made a mistake." So the customer totally disagreed and went to court. And the judge totally agreed with the customer. The judge said, "I don't mind if it's a human or a chatbot that puts stuff on your website. If you put it on your website, you have to honor it. Therefore, you have to refund the ticket." Next day, the chatbot was offline. And I think this story really illustrates a problem we have nowadays with LLMs. So I think they're great tools, and they offer a lot, but you can only trust them up to 90, 95%. And the problem is in the last 5 to 10%. But lucky for us, we're going to use the LLM to generate code. And we have unit tests. So we're going to use the unit test to check if the output of the LLM is the correct output. We're going to use the unit test to see if the implementation is a correct implementation. And that's the second purpose of unit tests in this idea. So my name is Bouke Nijhuis. I'm the CTO at a company called Sync. And we're going to talk about TDD and GenAI. And together we're going to see if this is a perfect pairing. So I created a little schema to show off the way of working. I'm going to first start with the happy flow. So that starts on the left, and then it follows the arrows to the right. Afterwards, I'm going to talk about the loops in the model. So on the left, we have tests. Remember, first purpose of test is the input for GenAI. So we give the test to GenAI, and we prompt it with something like, "Please provide an implementation that passes this test." Now remember, happy flow, so everything, we get a perfect implementation. Now we're in the middle, in the box in the middle that says implementation. Perfect implementation, therefore all tests pass. We follow the yes arrow, and we're done. If you trust your tests, you trust the output of this method. This is how it works in theory. Unfortunately, we also have something called practice. And in practice, things go wrong. And that's why we have loops in the model. There are 2 loops, and I start with a small loop underneath GenAI. I call this the code loop. This is where we ask GenAI for code, but sometimes it comes up with explanations instead of an implementation. That's not good enough. Sometimes GenAI comes up with partial code or non-compiling code, also not good enough. Then when we go to the big loop on top, sometimes not all tests pass. If that happens, we extract the message from the test and we feed it back to GenAI. And this is how we get a feedback loop. This is the idea. So the best way to show off an idea, of course, is by giving a demo. And I would like to start really easy with something called the odd-even test. Don't worry, there will be more difficult examples in the presentation, so it will become more interesting. But this is to show off the procedure. First, I have to show you this test, and then we're gonna see it in action. So I created a small class called odd-even test, and it's just a JUnit 5 test, and it expects a class called odd-even to be there, and it should at least have one method called isEven. If you provide it with even number, it should return true. And if I provide it with an odd number, it should return false. So like I said, really simple. I'm just showing off the procedure. So audience, I have a choice for you. we're going to use a GenAI, and you can choose between good old ChatGPT or runner-up Claude. So who wants me to use ChatGPT? 10%. Who wants me to use Claude? 60%. 30% is undecided. Great. I expected that, so I have Claude. But I also prepared ChatGPT. Yeah, I have both. So what I'm going to do, I'm going to select everything. I'm going to copy it. I'm going to go to Claude, and I'm going to ask it, please provide an implementation that passes this test. I paste the code. I didn't paste any code, so we retry. Just press enter, let's see what happens. That's the thing with live demos, right? Things go wrong. Okay, Claude comes up with an implementation which looks correct, right? This is what we expected. So we're just gonna copy this. We're gonna go back to our editor. We're gonna go to the test subject. Notice that I have a dummy implementation here, which is incorrect. I'm gonna select everything. I'm gonna paste the code from Claude, and something is wrong. Nice. Let me see. It's missing a package. Okay, cool. Now this is interesting. Let me tell you a little bit about this. This is the first time I practiced like 10 to 20 times, and this is the first time that it fails. But there was a funny thing. This morning it said it's really busy and we're using Claude Haiku instead of Sonnet. So normally I use the Sonnet one and it comes up with a perfect implementation. Doesn't really matter for now. But yeah, it's a little bit unprofessional that the demo didn't work properly. But that's LLMs for you, right? You can never predict what they do. Now I go back to the test. I run the test and I hope for a green check mark. And look at that, green check mark. Okay, this was a really, really simple example, but like I said before, to show off the procedure. So let's do something a little bit more interesting, which is prime number generation. I also have a test for that, prime number generation, this one. And again, JUnit 5 test. We expect a class called prime number generator to be there. We expect it to have at least one method called generate. This method takes one integer as an input. It denotes the upper bound of the prime numbers to generate. So if we provide it with 50, we expect it to return those prime numbers. Now we're going to do exactly the same. I'm going to copy the code. I'm going to go to Claude. I'm going to paste it. It's smart enough to know that I want an implementation. And we wait, and there is an implementation. Let's hope that it this time gave a proper implementation. We're not really going to look at the code because we don't really care. So we go to the dummy implementation. I select everything. I paste the code. And again, something is wrong. Wow. Probably, again, I'm missing the package. Let me see if IntelliJ can fix that for me. Yes, there it is. And let's go back to the test. And let's run the test. And a green check mark. Really, really nice. So the AI is pretty capable of coming up with an implementation when I provide test cases. I had a question.
Are you not missing the negative ones? The ones that shouldn't be in prime?
Yeah, I just kept it really simple, just to show off that it will be better. There are a lot of questions. Actually, I prefer my questions at the end. Let's do those two, and then you were first.
Yeah, you're describing the problem in your test. So you're talking about primes. What happens if you use bogus language and just enter the data?
Yeah, let me repeat the question for people watching on YouTube. The LLM can get a lot of information from all the variable names, the names of the tests, right? That's what you're, yeah. So I also did tests with that. If I anonymize everything, so use A, B, C, single letters, it still works. So, but on the other hand, why not give the LLM extra information? We want proper implementations, right? So it does work, but I don't see the point for this. It's interesting from a research perspective, but if you want to have working implementation, just give it as much information as it needs. Yeah.
My question was exactly the same.
Excellent, excellent. Yeah, so back to the slides. The principle works. Thank you for attending my talk. Have a nice conference. No, just kidding, just kidding. So I'm really happy that the principle works, but there are two major issues with this idea. And the first one is too many manual steps. Let me rehash the process. I was in my IDE, I had to select all the code in the test. I had to copy it, go to my browser, type in a prompt, paste the code, press enter, wait for an answer, copy the implementation from the LLM, back to my IDE, go to the test subject, select everything, paste everything, run the test, wait for the output. Just talking about this makes me tired. So we have to do better. And what do we do when we have too many manual steps? Very good, you saw the slides, right? Thank you. So my idea was, let's automate this. So that's what I did. And sounds pretty simple, right? There were a lot of steps, but you just saw me doing it. I did a little bit in the IDE, a little bit in the browser. How complex can it be? Yeah, it turned out to be a little bit harder than I expected. So what did I expect? I expected to spend 3 to 5 evenings on it, and then I should have a working tool, right? In the end, I spent 10 to 15 evenings and a few weekends. But I learned something. I learned that the IDE does a lot of work for me. And of course, I already knew that the IDE does a lot of work for me, otherwise I wouldn't use it. But it became really apparent while building this tool, and I'll get back to this in a minute. But in the end, I had a tool called the test-driven generator. And of course, I'm going to show off this tool in this presentation, but for now, I first would like to take you through the steps. So, you probably recognize this as part of the schema I've showed you before. And the first thing that the tool does is it needs to call an AI, an API from a Gen AI. I started building this in the beginning of the year, and I was most familiar with the API of ChatGPT, so I started out by using that one. It's not difficult, but it's work. It takes some time to build this. Secondly, you have to interpret the reply. And that sounds really simple, but when you're using... No, let me tell it differently. You saw me doing it in Claude, right? It just there was a nice pop-up, and you directly knew this is code, and the other part is explanation. But if you use different LLMs, they all use a different way to make a difference, to differentiate between code and explanation. So you need to find a way that works for multiple LLMs. I used multiple LLMs later in the process. I talk about that later as well. So sounds simple is a little bit more difficult than you think. Then you have to create a file. And as you all know, the file name has to be equal to the public class name in Java, right? So I need a feature to extract the public class name from a piece of code. Then you have to put the file in the right spot. Because if you use a package, you need to build the right folder structure, otherwise it doesn't run. Again, not difficult steps, but it takes a little bit of work. Then you have to compile both files. And I totally forgot about this part. I never manually compile files anymore. You have to compile the test file, you have to compile the implementation. This is typically something that the IDE takes care of for me. I don't think about this anymore. And the same applied for this. After compiling, you have to load both classes. Who loads classes manually? Nobody, right? The IDE takes care of this for you. So the IDE does a really good job of taking work from your hands. Then you have to add the test library. Also something, normally when I start a new project, I add JUnit 5 to the POM file and I forget about it. But now this tool needs to run the test. So I had to add it manually to the tool, otherwise you cannot run test. Didn't think about that, more work than I expected. Then you have to run the test from code. Normally I press the green triangle or Shift Command R. And it just works. But now you have to run it from code, which is totally possible, but again, extra work. Once all tests pass, I copy the implementation back to the project where the test file came from, so you can directly use it. Then about the loop. If not all tests pass, you extract the errors. So you extract the file name, the message from the test that is failing. You feed it back to Gen AI, and then you have to continue the conversation. You saw me talking to Claude in a browser, and when you keep talking to Claude, it remembers what you talked about before. It keeps context. This is not true when you're using the API. So you have to build your own context mechanism. I didn't know. Again, extra work. And lastly, I started out with a few system out print lines, like every project. But yeah, you saw the schema with the loops. Every time the input is a file with code, so multiple lines of code. The output is an implementation, also multiple lines of code. So if you do a few loops through the schema, you get a lot of lines of codes, and you want to log it somewhere to see if something goes wrong, what exactly went wrong. So I needed a proper logging mechanism. So hopefully you now understand why it took me a little bit more than 3 to 5 evenings. And this is not even the end result, so there's more. Okay, I told you I started out with JetGPT, but I heard more and more about local LLMs. So I decided, let's give them a try. And I noticed that they're far easier and they were far faster than I expected. What did I expect? I expected to do 20 manual error-prone steps, and then hopefully the LLM will start and do something. It turns out it's really simple. You just download a tool called Ollama, you run a model, and it just works. Also, I expected the answers to take up to minutes, but when I started with this project, I was on an M1 Mac, and the answers took like tens of seconds. And nowadays, I'm on an M3 Max, and the answers sometimes even take less than 10 seconds. So it's much faster than I expected. So there are lots and lots of local coding LLMs out there. I tried a few, but in the end, I settled on Llama 3.1. I know there's also a 3.2, but it contained a few small models, which it didn't improve my answers. It also contained a few big models, which were multimodal, but I don't need voice or sound or pictures. I just want code. So I stayed put with 3.1. So all the demos I'm going to give from now on will be with Llama 3.1 unless I say it's with something different. Running locally on my machine. Okay, demo time. What we're going to do, reminder for me, I always forget to do a reset. So I'm going to get rid of all the answers from Claude. So now we have clean slate again. And what we're going to do again prime number generator test, but now with a tool. So the tool in its current form is a jar file. So it's just a jar running somewhere else on my hard disk. And its most important input is the path to the file the path to the test file. So I'm going to copy the path to the file on top. I'm going to paste it over here. I'm going to press enter. Now, and you can see the logging. So we're in the first test loop. Every test loop can have 5 code loops, and we can have a maximum of 5 test loops. So in total, you can have 25 attempts to come to the right solution. And as you can see, within 8 seconds, my local LLM came up with an answer. We can take a look at the answer, but hey, the test succeeded. If you trust your test, you trust the output of this tool. Therefore, we're not going to take a look at that. It just works. The tool works too, and this is really cool, because now I can use the idea of test-driven generation, but without all the manual steps, which is much, much nicer. So now we have the tool. Let's talk about the implications of working this way. So how would you add features? In the past, I would open up my IDE and I would just write more algorithms to add features to my code base. But hey, the implementation is now the domain of the LLM. I'm not touching it anymore. Therefore, the only thing that I am allowed to touch is the tests. And that's exactly the answer. You just write more tests if you want more features. So let me show you how that works. And let's talk about negative prime numbers. So remember this test, and I told you this 50 is the upper bound of the prime numbers to generate. If you would provide a negative number here, you're asking for negative prime numbers. As far as I know, they do not exist. Therefore, I'm going to write a test. Therefore, I want the generated code to throw an exception whenever the user asks for negative prime numbers. So how do you do that? You add a test. So I'm just going to add a test. I really like this. It's incorrect, but this is the one-line completion from IntelliJ. It's really fast and really cool. You have an under 50 method, so probably you also want an over 50 method. I think that's pretty cool. It's incorrect, so I'm going to change it. I'm going to call it negative input. And now it says, you probably want a prime number generator. That's correct. And this is incorrect. What I want is something called assert throws. So this. And notice this, again, it comes up with something that is exactly what I want. I'm going to accept it and then explain it. So how does the assert throws work? The first parameter is the exception that you expect. So in this case, I expect an illegal argument exception. And the second part is a lambda that should cause the exception. So a piece of code that in the end should throw an illegal argument exception. And notice that it put a negative number over here. So I'm going to run exactly the same command in the terminal, but the only difference is that it now points to a file containing 2 test files, where it only, in the previous example, it contained only 1. And look, it found 2 tests, and they both succeeded. Let's see if we can find a piece of code that corresponds to this second test. And as you can see, this is what it added. So, if you want more features, you just add tests. And it feels really natural. If you're already using TDD, normally when you want more features, you first write the test for the feature, and then you start implementing it. Only in this case, you don't have to implement it anymore. That's the big advantage. So what about real code? So all the examples I gave up till now were like playthings, right? It's not real. So most of us in the room are developers, I assume, and you all have written hundreds, thousands, maybe tens of thousands of unit tests. So you could also use this tool against those existing unit tests. And maybe it comes up with something better than you wrote. At least it happened in my case. Maybe it will not happen in your case, but it happened in my case. So I used the tool to improve the tool. Now let me explain that. In the tool is a class called the code container. And the code container holds the code that comes out of the LLM. And it has 2 features. The first feature is it has to be capable of extracting the public class name. And we use that to write the proper Java file name. And the second feature is it needs to be able to extract the part behind the package keyword. And we use that to create the folder structure in which we put the Java file, the generated Java file. So what I'm doing is extracting text from text, right? And in a lot of cases, the best way of solving this kind of problem is by using a regular expression. Confession time. I am really bad at using regular expressions. I think they're hard. I think they're written for computers, not for humans. So I wrote a poor man's substring implementation. And hey, it worked. For a time. Until I started adding some test cases. It broke. I fixed it. More test cases, broke again. So in the end, I needed something better. And I decided to use the tool to improve the tool. Now, let me show it to you. I'm going to show you the code container test. A little bit space. So the first feature was extracting a file name, remember? And I have some classes over here. And notice that I have classes and public classes, and I put spaces in random spots. That's what really broke my substring solution. This really kept breaking. Then over here I have the expected answers, and then over here I have messages. I think adding messages to your test cases is really nice, especially for the developers who are coming after you. But in this case, it also really helps the LLM, because you give information about things that went wrong, so it has more information to come up with a better implementation. I'm doing something similar for package name extraction. So notice over here I have some small classes. I have single level packages, multiple level packages, again random spaces in random spots. And notice that I also have no package, because package is an optional construct in Java. Okay, let's copy the path to this file. Let's go to the terminal. Let's get rid of the last parameter and paste the path to the file on top. So this problem isn't really easy. I wrote a poor man's substring implementation. Let's see if AI can do better than I do. And as you already see, it's taking a little bit longer, and this is because this is a more complex problem. Now, this is interesting. The first attempt didn't deliver any compiling code. Therefore, it could not run any tests against it. So what you're seeing is a small loop underneath GenAI asking for implementations that work. And this is not going well. Normally, when I see this pattern emerge, probably it will not fix it. So what do we do when something doesn't work?
Off and on again.
Yeah, off and on. We retry. And especially when you're using an LLM, they're non-deterministic. They always come up with different answers. So retrying is a really viable strategy. So that's what we're going to do when it times out. It's at the 5th test loop, so probably you see no solution found. So let's retry it. In case this also doesn't work, the next thing I normally do, I check the logs. So let's go to the logs. What you see here is that I'm using Olama, and I'm using Llama 3.1. Then you see part of my prompt. Then you see the test file that I showed you before. And then you see the answer from the LLM. And interesting thing, if you look down here, it comes up with implementations that are run. We can run tests against it. In the beginning, nothing succeeded. Then one succeeded. So the feedback loop is working. But in the end, it failed. This is also exceptional. Normally when you practice, 80% of the time this works. So now we're going to go to the next step. If the local LLM cannot solve this problem, let's go to a cloud LLM. I told you I'm really happy with the local ones, but the cloud ones are still so much better than the local ones. So what we're going to do, we're going to add, whoa, wrong button, we're going to add some flags. So I'm going to say this is test file. And then at the end I say use something from the entrophic family. So what happens if you do this? Let's go to the generated log. You see now I'm using entrophic, and now it uses Claude 3.5 Sonnet, the latest model. So it goes to the cloud and tries to solve the problem there. And as you can see, that went far, far smoother. Within 10 seconds, we had a solution. So I used the tool to improve the tool. Oh, let me also show you. That was better. Let me see what it. I expected to come up with something that uses regular expressions. And of course it didn't. It came up with a string manipulation solution, which also works if you do it properly. Now, let's redo this just to see what happens, because normally it comes up with a regular expression. Live as a presenter is really fun, especially when you're doing live demos with LLMs. There's always a surprise what it comes up with. And let's see what happened now. Nah, nothing changed, right? Okay, hey, the tests succeed, so we have working code. You can put it in production, right? That's the idea behind the concept. So I told you in the beginning, I have two major issues with this idea. First was too many manual steps, so now we have a jar file, no more manual steps. But the second thing is, now we have a tool that is pretty capable of generating plain Java code. But that's not really what we do at work, right? That's not what we do at our daily job. We use libraries, we use frameworks. Probably most of you use Spring Boot. And that's a problem, because in its current form, the tool cannot handle libraries and frameworks. And that's logical, because the only input is a test file. And deducting from a test file which libraries and frameworks are using is next to impossible. So I started thinking, how can I solve this problem? Which part in the development cycle knows about my libraries and frameworks? Yeah, and if you think about it, it becomes really simple. It is, of course, the build system. The build system knows about your dependencies and therefore also knows about your libraries and your frameworks. So I decided to create a Maven plugin. Why Maven? Because I have far more experience with Maven than I have with Gradle. But the principles should also hold for Gradle or other build tools if you use even other build tools than that. Now, the idea behind creating the plugin is the fact that it knows about your dependencies and therefore about your libraries and frameworks. And I never wrote a Maven plugin before, so I looked it up and I expected it to load all dependencies for me, and then I could do the thing that the plugin should do. I was totally incorrect. It does not. But fortunately, when you're a Maven plugin, you do have easy access to all your dependencies. It's just a list of strings that point to jar files or directories on your system. So I wrote my own custom class loader that loads all the dependencies, and then I run the tool. So let's see if that works as well. So I have something called an endpoint test. And this is really a bad name because it's more of a Spring Boot hello world test, but hey, let's take a look. So this is a Spring Boot test for people who do not know Spring Boot. It always, most people use random ports, and this random port is filled in this variable. So if you see it somewhere, it's just a random port. Then we have a test REST template because we want to do a REST call, and we do a get on the root of localhost. And when we do that, we expect it to return hello world. So like I said, this is a Spring Boot hello world test. So I also told you we have a Maven plugin, so we should talk about the POM file. And there's a lot of stuff in there, but there's something new. There's a new plugin called the test-driven generation Maven plugin. And the most important part of the configuration is a path to a test file. And this path points to the file I've just shown you. So the Spring Boot Hello World example. If you want to run this, you go to the terminal and you type Maven test-driven generate, and then it will call the plugin. Now, you recognize those two lines. The plugin, of course, uses the jar file under the water. So this is already far more difficult than the examples I showed you before, because now it also needs to use Spring Boot, which is far more difficult than writing plain Java code. Fortunately, the tool was capable of coming up with a solution in 14 seconds. Let's take a look at the implementation. So it's a Spring Boot controller, which is a REST controller. We start up the Spring Boot application. We have a get mapping on / and we return hello world. This is exactly how I would have written it myself. But okay, I agree, this is again a toy example. Let's make it a little bit more difficult. So I also have something called the endpoint H test. And it's similar again, a Spring Boot test. And again, we have a test REST template. And here's the difference. You provide it with a birth date, and then you expect it to calculate the age. So if you're born on the first day of 20 this year, you're still 0. If you're born on the first day of 2020, you're 4. If you're born on the first day of 2000, you're 24. But if you're born on the last day of 2000, you still have to become 24, and you're 23, right? So also notice that the birth date is part of the URL. So we have an H endpoint, and then you provide the birth date as part of the URL. And then we expect it to return the age. Okay, now let's go to the POM file, update the path to this file. Like this. Then we go to the terminal, we rerun the command. Okay, this is on the edge of what a local LLM can solve. So I'm not sure if this demo is going to succeed, but you already know if it fails, we're just going to retry, and otherwise we just upgrade to a cloud large language model. Let me see how I'm doing for time. I have up till 40, I assume, or 30. So I have 11 minutes left. Okay, if this fails, we're directly going to go to a cloud LLM. Actually, I can prepare going to a cloud LLM. So you see over here, I have some stuff I can increment if I remove this line. It's exactly the same as what happened on the command line. It's starting to use Anthropic, and it will go to the cloud. It will use Cloud Sonnet 3.5. You see, you can also specify models. You can specify timeouts. You can specify server, really handy when you're testing. And you can also specify prompts. I'm not going to wait for it to finish. I'm just going to... Oh, it finished. Very good. I'm just going to redo it. But notice I uncommented this line. So now it's going to go to the clouds, talking to Anthropic, to Sonnet 3.5 in the cloud. And let's see what it comes up with. Build success in 9 seconds. Let's take a look. Interesting. I don't know where the file went. So let me see. Example endpoint age calculator. This here, right? Example. Yeah, I did. Oh, now it does. Okay. Thank you for helping me. So we have a Spring Boot application, which is a REST controller. We start it up, and it picked up that birth date should be part of the path, the URL. It uses a path variable. It parses the birth date, and then it made a mistake. You see? But this is my mistake. I only provided 4 examples. I should also provide it yesterday or today and tomorrow. I could also have provided a little hint. What you can do is you can provide a hint used today to compare the dates, and then the next time it will do that. But I'm running out of time, so I'm not going to show that to you, but believe me, it works.
Show you that you made a mistake, because even commenting in the code saying, hey.
Yeah. So yeah, this is what I normally see. So it even helps me out. But I wanted to state you that I made a mistake, not the LLM. So again, if you trust your test, if you trust yourself, then you trust the output. But you should provide proper input. It subtracts the 2 dates and then extracts the years from the date. So almost the same solution as I would have written. I would have replaced this by today, and the rest is the same. So the Maven plugin works too, and that's really cool because now we have something that we can use at work. So picture this: you write your tests, you run the tool, you grab a cup of coffee, you come back, and hopefully your work is done. You saved a lot of hours. So what does work well? Plain Java code. The first few demos were I showed you of the generation of plain Java code, and it works really well because there are a lot of examples of Java code on the internet, and the LLM is trained on that. The same applies for well-known dependencies. If you use dependencies which have a lot of examples on the internet, the LLM will work with it and it will come up with proper code. What does not work well? References to your own code. Currently, the LLM only knows about the only input is the test file, therefore it doesn't have your entire project context. This is easily solvable by adding this, by sending this as well to the LLM, but I didn't implement that yet. Also, less known dependencies, it doesn't know about it, therefore it will not probably use them properly. So what if it doesn't work? You've seen this happening during this presentation, so you already know. First thing we do, we retry. It's an LLM, so just retry. Check the logs. Maybe something went wrong. Maybe there's a bug in the tool. Something happened that you didn't expect. But if you do not find anything strange in the logs, then we upgrade the LLM. So we go from a local LLM to a cloud LLM because they're just better. But what if it still doesn't work? Then at least you have the unit test. Hear me out. In the past, I would write my unit test, I would grab a cup of coffee, and then I would write the implementation. Nowadays, I write my unit test, run the tool, takes less than a minute, grab a cup of coffee, and come back. If it didn't work, I only lost a minute, right? So it's not so bad. You have nothing to lose. That's what I'm trying to tell you here. So pricing. It's pretty non-existent when you're using a local LLM. Not entirely true. The battery of your laptop will die a little bit sooner, therefore your electric bill will be a little bit higher, but probably you will not notice it. You pay a small price when you're playing around, so building this tool, practicing, giving talks at conferences and meetups, it cost me less than 11 euros. Pretty doable. It will become pricey when you use it for every test that you have out there. But I really believe there will be a point in the future in which this is price effective. The most expensive part of a project are we. We are the most expensive part. So if you save 1 hour every day, you just make money. So it's a really, really simple business case. Also, the LLMs are getting cheaper, faster, and better by the week. So I'm pretty sure we will reach this point in the future in which it will be cost effective. Can I use this myself? Yes, you can. I will share 4 links afterwards. On the last slide will be 4 QR codes. The first one will be a link to this presentation. The second one will be a link to the repo containing the examples. The third one will be a link to the project that generates the jar file. And the fourth one will be the repo that creates the Maven plugin. Warning, it is proof of concept level. This is an idea. So it is not perfect, it is not production ready, but hey, you can play with it. So I have some ideas for the future. How much time do I have left? Oh, 5 minutes, nice. Now, currently the tool only accepts 1 test file. I want it to accept multiple test files because that's what sometimes happens, right? Should be a small change. I would like to provide context so it knows about the other parts of your project, that it can reuse parts of your project. I'm pretty sure if you provide the entire context, it will come up with better answers. Currently, the tool only accepts an answer from an LLM that contains exactly 1 compiling class. But sometimes it comes up with multiple classes, sometimes it comes up with partial code. If I can improve the tool to also accept those, we will have a better hit rate. Also, I would like it to have a hybrid mode. So the idea is to work together with the LLM. You write part of the implementation, but you leave to-dos for the LLM, and then the LLM can do the boring work. Then currently it supports Olama, JetGPT, and Anthropic. The far more AIs out there that I would like to support. Currently, it only supports JUnit 5, but hey, there are far more frameworks out there, JUnit 4, Spock, and even other interesting stuff. Should also be a small change. Then, currently it only supports Java, but the principle holds for every language. It should work for every other programming language out there. Then, my endpoint for this idea is an IDE plugin. I really would like to write my implementations, right-click, and wait. Sorry, I really would like to write my test, right-click on the test, and then ask for an implementation. That would be really, really nice. But I specifically said my endpoint because I think it should be part of Copilot, AI assistant of DevOps Genie. So if somebody has some spare time, free time, especially the last one, DevOps Genie is accepting PRs. Talk to me, talk to Stefan Janssen. I think I saw him somewhere in the public. Yeah. So then we can make this happen. So conclusion. TDD and GenAI is a perfect pairing. The principle works. I've shown off multiple demos in which I gave the test to the LLM and the LLM came up with working implementations. The most important thing that I can teach you is that we should check the output of large language models. Lucky for us, if you generate code, we have unit tests. We have an automated way of checking the output of large language models. And that's the principle behind this idea. Those are the 4 QR codes I promised. If you have any questions, please come to me after the talk. I prefer my questions one-on-one. Feedback is more than welcome. Please rate me in the app. Also talk to me down here, talk to me in the hallway. And we are hiring. If you're looking for a cool new job, talk to me and we can see what will happen. Thank you for listening to me. Enjoy the remainder of the conference. Bye-bye.